I'm Tom DeMarco, and we're going to talk a little bit today about how artificial intelligence works and how it can be used in the classroom. I'm not an artificial intelligence scientist. I'm a classroom teacher and former administrator, and we're going to take the point of view that this is for novices, and you can see how AI works and perhaps how you can use artificial intelligence in the classroom. AI, that's the acronym for artificial intelligence. It's everywhere. It touches all of us, and it is very hard to detect. Many times you'll probably be sitting there and you'll be talking to someone that you think is a real person, and it could be a robot, or maybe you're texting someone and you think it's a real person and it's a robot here. So just what is artificial intelligence? Well, you may think of it as back in, as an older movie here, 2001: A Space Odyssey, where the computer, HAL, took over the ship and tried to kill the astronauts. Or maybe you think of Arnold Schwarzenegger trying to save the world from the robots. Or maybe a young Matthew Broderick who's out there and he's able to save the world from nuclear destruction by tricking the computer into playing a tic-tac-toe game. Artificial intelligence is basically out there, and it makes predictions based on what it knows. In this case, you're very familiar with it if you have Netflix or any other kind of streaming service. You're trying to make predictions of what you would like to watch based on what you previously watched. Here's an example of Jeopardy, and Watson, which is IBM's computer, beat all the great contestants in Jeopardy. It went on to beat people in chess. They're beating a grandmaster. Is that an example of artificial intelligence? It is. Here's one that's closer to home here. My wife certainly knows this one here. This is the one where Amazon is serving up different products that you may like to buy. Or maybe think of it as an autopilot in an airplane. It's reading the instruments and making predictions and flying the plane based on what it sees. Or you got self-driving cars now, and it's out there doing the exact same thing as the autopilot on the plane is, looking at what it sees based on the cameras and the radar and everything else here, and it's driving the car. Now, artificial intelligence had a major breakthrough back around 2015, 2016. And what it was these large language models were produced. That's what it's called. Essentially and Google kind of started this. Essentially what Google did was it went out and said, go get out its spiders, and it sent its spiders all over the internet, and anything that was digitized, it tried to read it and collect it. So it went to the Library of Congress and Wikipedia, the internet, Twitter, Facebook, all over the place, and it gathered up New York Times, you get the idea, gathered up all this information. Now, it had all this information, and what was it going to do? Well, previously, artificial intelligence that we just kind of talked a little bit about here was rules-based. In other words, if you know all the rules, you can win the game of chess here. Okay? And that is what's called rules-based artificial intelligence. But in Asia, there's a game that's quite popular. It's called Go. And from what I've been told, I've never played the game. What I've been told, there's no way that you can learn all the rules of Go. There's an infinite number of rules. So the challenge was to write a program, use artificial intelligence to play Go against the best Go players. And that is what is called neural-based artificial intelligence. So how would you do that? Well, what they did was they told the computers to watch how Go players play the game. And they watched it thousands and thousands and thousands of times. And based on that, it was able to develop a strategy to beat the Go players. And that is called neural-based learning. So how did it do that? Well, I wish I was at this conference here, but imagine I wasn't. But here's the greatest artificial intelligence scientists are at a conference out in California here, and Google's doing a presentation, And they have sent their spiders across the internet to gather all the information, and then they've proceeded to write some software that can kind of connect that information together, because computers don't know words. Computers only know numbers, so you've got to assign a number to every word, and that's exactly what they did. They assigned a number to every word. Now, we think in 3 dimensions, 4 dimensions, length, width, height. Well, imagine that you're out there and you are going to create multiple dimensions, 1,000 dimensions, 10,000 dimensions. And these words are all going to be floating out there inside this vector. And they're going to be connected how the computer ranks them. And so when Google put this equation to the computer, and it said king minus man plus woman equals what? And the computer spits back queen. Half of the scientists started screaming that it was black magic. They tricked it. It's not really what it did. And they did this one here. Paris minus France plus Poland equals Warsaw. So you get the idea. The computer was able to gather all the information, and then inside it was able to make these connections, and that's where it gets a little scary, because nobody quite understands exactly how the connections are made, and it's able to produce a reasonable output. And that's what a large language model is. Okay, so you got connections. From connections you get predictions. And so when you present the large language model like ChatGPT, explain why a potato is like an apple, it's going to come back and it's going to say, well, a potato and an apple are both plant-based. A potato and an apple are both edible. A potato and an apple both have peels or skins. You get the idea here. That's what a large language model can do. So they wanted to see how accurate it is. And they started to test it. Now in 2017, here is some results of the test. Here's your graduate exam, AP Stats, AP Bio, all the way up to the bar exam here. And you can see it didn't do very good. A couple 80s, but most of the time it didn't do that great. But then around 2019, 2020, it got real good here. They tweaked up the software some more, and now as you can see, it's scoring just about 80% on all of the tests. Large language models, they're out there. Here are the big ones: Bard, ChatGPT, Claude, which is the Facebook one, I believe, and then you got Copilot. And the one that's interesting to me right now is Copilot. That's Microsoft's, and what it's doing is Microsoft has embedded it into their browser, so it's part of Edge right now, and it's also part of their tools. So when you use Word, you're going to be able to go and get hold of ChatGPT. Well, actually, get hold of Copilot from Word. You're going to be able to get hold of Copilot from PowerPoint and Access and Excel and so forth here. So even if you want to try to keep the kids from using this stuff, you're going to have trouble because it's embedded in the tools. And there are other things besides large language models now. Now we've got audio and video and art. And so you got DALL-E, which is an example of a drawing program, and it'll produce a picture based on your description, and it's pretty incredible actually. And you got Flicky, which is video based on your description, and then you got Boomy, which is audio based on your description. So basically what you're doing here is you're creating content. That's what a large language model is able to do. It can create content, and the content it creates is called generative AI, and that's what student peer review is. It's a form of generative AI, and you'll see how you can use it in the classroom, and you'll see how you can use it to create content, and hopefully it'll make you more efficient, and it'll make you more productive. Thanks for listening. Talk to you later.